Welcome back to the deep dive. Sometimes you read a book and it doesn't just add information. It genuinely rearranges how you think about things.
Absolutely, especially in business, right? So many books tell you exactly what to do, step by step.
Exactly, very prescriptive. But then there are these other books, these rare ones, that deliver these huge fundamental ideas. And often they do it best through a story, not just dry theory.
Yeah, those are the ones that stick. Because the story makes it relatable, intuitive, you feel the concepts.
And that's exactly what we're diving into today. We're looking at a truly seminal work, Eliyahu Goldratt's The Goal.
Ah, yes, the goal.
Now, it sounds maybe a bit different for our usual deep dives because it's actually a novel, a business novel.
Right, set in a manufacturing plant. But the impact, wow, it fundamentally changed project management forever.
And not just in manufacturing. That's the key thing. Its ideas have spread everywhere. Healthcare, software, and crucially for our discussion today, construction.
It's incredible how universal it turned out to be. Because Goldratt introduced this powerful idea, the theory of constraints, TOC.
Explain that a bit. What's the core idea of TOC?
At its heart, it's actually pretty simple but profound. Every complex system in a construction project is definitely complex, has one thing, a single bottleneck that limits its total output.
Which one?
Well, one primary one at any given time. And the real breakthrough is realizing that focusing your improvement efforts right there on that constraint is the only way to significantly lift the performance of the whole system.
Okay, so that's our mission for this deep dive. We're taking the lessons from Goldratt's factory floor and translating them straight onto a construction job site.
Which can be pretty chaotic, let's be honest.
Oh, absolutely. So we want you, our listeners, to learn how to spot your own Herbies. That's Goldratt's great term for bottlenecks in your projects.
Right, the Herbies could be anything.
Could be slow permits, maybe a specific trade that's holding things up, a critical piece of equipment everyone's waiting for, or, a sudden material shortage.
And understanding this, finding that Herbie, it was a huge influence on lean construction.
How so?
Well, it shifted the focus. Instead of just trying to make each individual task faster, like how fast can this one person lay bricks, lean started looking at the whole workflow.
Ah, okay. Seeing the bigger picture.
Exactly. And systematically removing the roadblocks, the Herbies that were stopping the entire project from flowing smoothly.
So get ready, because the big message here is powerful. Optimizing the parts does not optimize the whole system.
It's such a crucial lesson for project management, isn't it? Seeing that entire value stream.
It really is. And grasping this can unlock, honestly, whole new levels of efficiency and, frankly, less frustration on your projects.
Yeah.
So let's dig in and find those Herbies. All right, let's really unpack this core revolution that the goal sparked, this idea of understanding constraints. The theory of constraints, TOC. What exactly is it at its foundation?
Okay, so the foundational principle is this. In any system that has multiple steps or components working together, think a factory line, a hospital emergency room, a construction schedule, there's always something acting as the limiting factor.
The weakest link, basically.
Precisely. The weakest link, the bottleneck, the constraint. And Goldratt's big assertion was, if you want to improve the overall output of that system, you must focus on improving that constraint.
Not anywhere else.
Well, improving things that aren't the constraint might make those specific parts look busier or more efficient locally, but it won't actually increase the system's total output. The system can only move as fast as its slowest part, its bottleneck.
He had that great analogy, didn't he? The river and the rocks. Can you walk us through that?
Oh yeah, it's brilliant because it makes it so visual. Imagine a river flowing. You want to find the rocks, the obstacles hidden beneath the surface that are slowing down the water?
Okay.
Do you try to randomly clear out small pebbles everywhere? No. Goldratt said you need to lower the water level.
Lower the water. Ah, okay.
As the water level drops, the biggest rocks, the ones really impeding the flow, those are your constraints. They become obvious. They're revealed.
So in project management terms, we need to lower the water somehow to see what's really holding things up.
Exactly. Systematically identify what's blocking progress. But, and this is important, it's not about blaming that rock or that person or that department. It's about understanding the system and how its structure creates that bottleneck. It's systemic identification.
That systemic view is key because it stops us from just jumping to superficial fixes, right?
Mm-hmm.
Goldratt talked about science being about understanding the way the world is and why it is that way. He focused on cause and effect.
He really did. It's about digging deeper than the symptoms. Let's say your framing crew is always behind schedule. The superficial reaction might be they need to work faster.
Yeah, push them harder.
Right.
Yeah.
But a cause and effect analysis, Goldratt style, asks why are they behind? Is it waiting for foundation work? Are the materials late? Are the plans unclear? Maybe the bottleneck isn't the crew at all, but something happening upstream.
So you fix the root cause, not just the symptom.
Precisely. Otherwise, the problem just pops up somewhere else or keeps recurring. You need sustainable solutions, not just quick patches. It's about asking why multiple times.
And he had this interesting take, saying he didn't believe in absolute truths because they block the search for better understanding. That sounds potentially controversial in business.
It is, but it's central to TOC. If you think you've found the absolute truth or the one best way to do something, you stop looking for improvements. You get complacent.
You shut down curiosity.
Exactly. Goldratt encouraged this constant questioning, this open-mindedness, always asking, why does our system behave this way? Could there be a better way? It keeps you searching, keeps you improving, prevents getting stuck just because we've always done it this way.
Now let's talk about the book itself. The goal. Why a novel? That seems unusual for a business theory book.
That was Goldratt's genius, really. He knew these ideas could be complex, maybe dry if presented academically, so he wrapped them in a story.
Making it accessible.
Totally. He said it himself. It makes the principles more understandable and shows how they bring order to the chaos. It's not a textbook you slog through. It's a human story about a factory manager, Alex Rogo, trying to save his plant.
You relate to the characters, the struggles.
You do. You see your own challenges reflected in theirs. It makes the abstract concepts concrete and memorable. You experience the theory playing out.
It reminds me of that story about Louis Sullivan, the architect. He talked about a kid bored by abstract math problems about building walls.
Yes. The kid wanted to know where the wall was, who it was for.
Exactly. We need that context, that human element, to really engage with problems. It's not just numbers on a spreadsheet.
That's why narrative works. It grounds the problem. Alex Rogo's struggle feels real, so the solutions he discovers feel real and applicable too. It makes learning almost subconscious.
And the book also warns against just drowning in data, right? Organizing monstrous piles of facts without purpose.
Oh, definitely. It shows how teams can create these impressive-looking reports, fancy graphics and all, but they're useless, pompous, if they don't actually point to the real problem, the constraint.
That feels very relevant today with so much data available.
It is. Just having data isn't enough. You need the right data, analyzed in a way that highlights the constraint and guides action. Otherwise, it's just noise. The story constantly pulls focus back to what matters, the system's output and the bottleneck limiting it.
And Goldratt really believed these ideas went way beyond manufacturing. He hoped people would see them applied to banks, hospitals, even families.
He did. And that's been proven true. The concept of a limiting factor is everywhere. There's a great story about that, actually, from a Dutch consultant.
Oh, yeah?
Yeah, he was applying TOC to his office supply company, looking for production bottlenecks inside, like in the book. But Goldratt challenged him, told him to think outside the box.
So the bottleneck wasn't internal.
Exactly. Turns out the real constraint was in the market. They weren't selling effectively enough or understanding what customers truly needed.
Wow. So the biggest problem was external. How do you even spot that?
It's tough because we naturally look inwards, but sometimes the biggest barrier is customer demand or regulations or competition. For this Dutch company, realizing this shifted everything.
How did they adapt?
They focused on precisely meeting customer needs, which actually let them reduce internal hassle and overstocking. They ended up dropping their total cost of providing office supplies by 50%.
50%.
Yeah. And their margins shot up way above the industry average, over 30%, while keeping customers extremely satisfied. It shows the constraint isn't always where you expect it. It might be completely outside your direct control, requiring totally different solutions.
Okay, that's a perfect lead-in to talking about construction specifically. Because if any environment is a complex, dynamic, interconnected system, it's a construction site.
Oh, absolutely. It's inherently complex and getting more so all the time. You have this dense web of dependencies. Everything relies on something else finishing first.
And even the way we manage projects is evolving to reflect this, right? You mentioned the PMBO guide shifting.
Yes, exactly. Project management is evolving more rapidly than ever before. The PMBO guide, which is, a major standard, moved away from being purely process-based, very prescriptive, like a checklist.
Okay.
Now it's more principles-based, focusing on intended outcomes rather than deliverables.
What's the practical difference there? More freedom for the PM?
It's more about focusing on the why and the result. It aligns beautifully with TOC because instead of just checking boxes, did I complete task X,
Hmm.
you're asking, is this task actually moving us toward the overall project goal? Is it helping the system flow or just keeping one team busy?
So it encourages that adaptive, holistic thinking.
Right. Less rigid process, more focus on achieving the actual goal and delivering value, which means you have to understand the system and its constraints.
And in construction, the interconnections are just massive.
Yeah.
Architecture affects structure, structure affects foundations, everything affects MEP.
Precisely. Halpin and Senior, in their construction management book, stress how these designs are all interlinked. A small change in one area just ripples outwards.
Like a domino effect.
Exactly. Moving one wall might impact structural loads, which changes foundation needs, which means relocating plumbing stacks. It can cascade quickly and create new bottlenecks if you're not looking at the whole picture.
And finding the real cause of a problem in that web can be tricky. The issue you see might not be the root cause at all.
This is where that systemic thinking is so crucial. Thinking in systems talks about how actual causes may be deeply hidden or lie in the very structure of the system itself.
Give me an example in construction.
Okay, say your mechanical contractor is always late installing ductwork. Your gut reaction might be to pressure them. But the real cause, the hidden one, might be that the steel fabricator is consistently delivering late, which delays the deck pours, which means the mechanical guys physically can't get into the area when scheduled.
So the bottleneck is way upstream.
Right. Your intuition might point to the mechanical guys, but it's inadequate to complex systems. You need to trace back the dependencies to find the true structural constraint.
Okay, let's get specific then. What are some common Herbies, these bottlenecks, that construction folks listening might recognize on their job sites?
Oh, there's some classics. A huge one, often before you even break ground, is permitting and approvals.
The paper chase.
Absolutely. That gauntlet of permits, local, state, federal, environmental, you name it. Bureaucratic delays can just stop a project dead in its tracks for weeks, even months.
Even if you have crews and materials ready to go.
Makes no difference. If you don't have that piece of paper, nothing happens. That permit process can absolutely be the primary constraint, completely outside your site operations.
Okay, what about once work starts? On the site itself?
Then you often run into constraints with specific trades or just general labor shortages. Think about a specialized trade, maybe curtain wall installers or terrazzo finishers.
Right, not always easy to find enough skilled people.
Exactly. If that trade falls behind or you can't get enough crews, everything downstream that depends on them gets delayed. Steel erection waits for foundations, drywall waits for MEP rough-in, finishes wait for drywall. It becomes a cascade.
And it's not about how fast they work when they are working, necessarily.
Not always. It's often about their capacity relative to the project's overall tempo. If the project needs them to complete 10 units a week, but they only have the capacity for 8, they become the bottleneck, dictating the pace.
And materials, of course. We've all felt supply chain pain recently.
Hugely significant. The timely provision of necessary materials is critical. A shortage of something specific, structural steel, roofing membranes, even specialized fasteners can bring everything to a halt.
It's not a new problem, though, is it, even historically?
Not at all. Think medieval builders favoring Gothic arches with quite small stones? Why? Because transportation of large masses became increasingly difficult. The logistics, the supply chain, was a major constraint shaping design itself.
That's fascinating. Logistics as a design driver.
Yeah. And today, it's global supply chains, disruptions. You need robust plans. PMBOK stresses integrating logistics plans with material and delivery needs. It's fundamental.
You mentioned Vitruvius, the Roman architect, talking about bricks needing years to cure properly. That's an incredible material constraint.
Isn't it? He said bricks were most serviceable if made 2 years before using, maybe even 5. Because fresh bricks would shrink and crack in the wall, ruining the structure.
5 years lead time.
Yeah. It shows that managing long lead items and inherent material properties has always been part of construction. It requires serious foresight and planning.
Okay, besides physical stuff, what about information? That must be a huge bottleneck potential.
Enormous. Especially now with digital tools. Historically, managing consistency across drawings was onerous, lots of manual checking. Now with BIM, building information modeling, the goal is project synchronization.
Keeping all the digital models aligned.
Right. Making sure the architectural, structural MEP models don't clash. BIM's clash detection feature is specifically designed to find information bottlenecks like a pipe hitting a beam before it happens on site.
Catching it virtually instead of physically.
Exactly, saves huge amounts of time and money. The Project Management Institute even lists information flow as a key value delivery component now. It's critical.
Which implies that design itself, the decisions made early on, can become constraints later.
Oh, absolutely. Early design decisions have massive downstream leverage. A poor decision early on, or a late change, can have unanticipated or unwanted consequences that ripple through the entire project.
So things like value engineering become important.
Crucial. Value analysis and engineering studies aim for the purpose of optimizing value in project designs, trying to avoid costly late changes, and involving contractors and key suppliers early.
Getting their input during design.
Yes, getting that practical input early provides valuable information to the design team. They can make more informed choices, understanding the construction implications, which impacts the whole project lifecycle. Delaying those inputs creates risk.
And then there are the big tools, the physical machinery. Cranes, pumps.
Yep, equipment and resource limitations. The physical stuff. Thinking in systems makes a great point. Physical structure is rarely a leverage point because changing it is rarely quick or simple. You can't just snap your fingers and get another tower crane mid-project.
Right.
So the leverage point is understanding its limitations and bottlenecks, using it with maximum efficiency. If your one crane dictates the pace for steel, facade, and material hoisting, its utilization is the constraint. It's your Herbie. You have to schedule around its capacity.
It makes you think about historical engineers, like Brunel. Were they intuitively managing constraints even without the formal theory?
I think the great ones absolutely were. Look at Brunel building the Great Western Railway. He famously insisted on surveying only one road, the best, not the cheapest.
He wasn't just minimizing upfront cost.
No, he gambled to win or lose all on one bold stroke. He understood that optimizing the overall outcome, the best, most efficient route long-term, was more important than saving pennies on the initial survey. He was managing the strategic constraint of quality and scope.
Seeing the whole system value. What about launching the Great Eastern? That massive ship must have been a constraint nightmare.
Unbelievable challenges. Brunel himself said floating the ship was the most difficult and hazardous part. Success wasn't just about his calculations. It depended on unpredictable vagaries of wind, weather, and tide.
External factors he couldn't control.
Exactly. So what did he do? He identified the biggest risk, losing control during the launch, and focused his resources there. He made sure the checking tackle was equal to any demands because failure meant complete disaster.
He managed the biggest constraint meticulously.
Pure constraint management. He identified the highest risk, the point where failure was catastrophic, and poured his effort into mitigating that specific constraint, even if other things had to wait or be compromised.
This all leads beautifully into that core, perhaps counterintuitive lesson from the goal. Optimizing the individual parts doesn't optimize the whole system.
It's the central pillar, isn't it? And it goes against so much traditional management thinking, which often focuses on maximizing the efficiency of each separate department or task.
Right. Make everyone look busy, make every machine run 100% of the time.
But Goldratt showed that this local optimization often leads to suboptimal performance for the project as a whole. His characters found their over-concern about the proper way to arrange things locally could be actively harmful.
How so in construction? Give me an example.
Okay, imagine pushing your drywall crew to be hyper-efficient. They hang board incredibly fast, way ahead of schedule in Area A. But the MEP inspection for Area A isn't scheduled for 2 weeks.
So the drywall is up, but nothing else can happen there.
Exactly. And now maybe that crew moves to Area B, but the framing isn't quite ready there. So you've got a super efficient drywall crew creating bottlenecks elsewhere, or maybe just building up inventory, finished walls that can't be advanced. Their local optimum hurt the overall flow.
So trying to maximize utilization everywhere can actually backfire. That's tough for managers to accept sometimes. How do you justify having, say, a crew deliberately wait sometimes?
It is a mindset shift. But think about traffic again. If everyone floors it, you get jams. Smooth flow requires matching speed to conditions. In construction, if the concrete pump is your bottleneck, making the formwork crew work faster than the pump can handle just creates piles of forms or stop-starting efficiency.
You subordinate the non-bottleneck to the bottleneck.
Precisely. Match the pace of everything else to the capacity of the constraint. It might look like the formwork crew has downtime, but the overall rate of completed, usable concrete placement improves. It becomes smoother, more predictable. Thinking in systems calls delays and feedback loops causes of oscillations like the boom and bust cycles in building power plants because of the long delay between decision and operation. Local optimization doesn't help if the feedback is slow.
And if you don't see the whole system, these problems just keep happening, right? They get baked in.
Exactly. That quote from How Buildings Learn is perfect. What is the systemic breakdown that leaves a problem unnoticed, unreported, unacted on, unsolved? Without that feedback loop, the system can't learn or adapt. Problems become chronic because the individual parts aren't working together to solve the overall issue.
Which explains why the goal was such a foundational influence on lean construction. It seems like lean took this holistic idea and ran with it.
Absolutely. It was a direct influence. Lean shifted focus from just making individual tasks faster to optimizing the entire workflow and the removal of roadblocks.
Flow over isolated speed.
Exactly. Because speed in one area is useless, even harmful if the next step isn't ready. Lean prioritizes smooth, reliable handoffs and continuous flow across a whole project.
And the last planner system, a core part of lean, sounds like TOC in practice.
It really is. LPS aims to improve workflow reliability by doing exactly what Goldratt suggested, systematically lowering the river to reveal the rocks.
How does pull planning fit in?
Pull planning is key. Instead of pushing work onto crews based on a master schedule, you work backward from milestones. The people doing the work identify, define, and sequence tasks based on what the next trade needs. It creates this logic network driven by downstream demand.
So work is only started when the next step is actually ready for it.
Right. It prevents that buildup of work in progress and forces constraints out into the open in real-time planning sessions. It ensures the last planner, the foreman, makes reliable commitments because they've confirmed prerequisites are met.
That's a world away from just using bar charts or even just standard CPM schedules.
Yeah. It is. Bar charts showed what and when, but not why things were linked. CPM software added the how, showing dependencies and the critical path. But TOC and Lean add the active management layer, not just seeing the path, but managing the flow along it, actively busting constraints. It's operational.
And this holistic view isn't just about speed or efficiency, it's ultimately about delivering value.
Correct. It's not just about building faster or cheaper in isolation. It's about optimizing value. Think about value engineering studies. They look at the whole life cycle, capital, operating, and maintenance costs, to find the most cost-effective design solution that truly delivers what the client needs long-term.
Getting the best bang for the buck over the building's entire life.
Exactly. And the PMBOK guides focus now on a system for value delivery fits perfectly.
Yeah.
You define what value means for this project. Maybe it's speed to market, maybe energy efficiency, maybe low maintenance, and then you align the entire system, managing constraints, to deliver that specific value.
It's like that Louis Sullivan idea again. Function must predetermine and organize its form. The project's function, its value proposition,
should dictate the form of its management, yes. You identify and manage constraints specifically to best achieve that ultimate function, rather than letting arbitrary processes or silos dictate the flow. Tailor the execution to the strategic goal.
Okay, theory is great. Understanding the concepts is crucial. But let's get down to the nitty-gritty. How do project teams actually apply this on a construction site? What are the practical tools and, maybe more importantly, the mindsets needed?
Right, the how-to. Well, first, you can't manage what you don't measure, especially the constraint. So establishing effective measures is step one. You need to track the right things.
Not just tracking everything, but tracking the constraint's performance.
Exactly. Tracking, evaluating, reporting this gives the team the data to make timely decisions and take effective actions. KPIs, key performance indicators, need to be focused. Maybe it's not just % complete, but daily throughput of the concrete crew, if that's your Herbie, or average approval time for RFIs if information flow is the issue.
Okay, so you're measuring the bottleneck. What happens when something goes wrong? A variance, a defect.
Don't just patch it. That's where root cause analysis comes in. You have to dig down to determine the basic underlying reason. If you just fix the symptom, say rework faulty wiring without asking why it was faulty, it'll happen again.
So is it unclear drawings, wrong materials, insufficient training?
Exactly. Finding that root cause prevents the same bottleneck, the same Herbie, from popping up again later, maybe disguised as something else.
And given how much things change on site, day to day, a rigid plan seems doomed. How do you stay flexible?
That's where techniques like rolling wave planning are so valuable. It fits perfectly with managing constraints in a dynamic environment.
How did that work?
You plan in detail, only for the near term, maybe the next few weeks. The work further out is planned at a higher level. As you get closer, you refine the detail.
So you maintain flexibility.
Precisely. It lets you adapt as constraints emerge or shift. You're constantly integrating new information and adjusting the plan, keeping it realistic and focused on the immediate hurdles.
And since every project is different, you can't just use the same template everywhere, right?
Absolutely not. The PMBOK guide stresses tailoring, deliberately adapting your approach, your tools, your processes to make them more suitable for the given environment and the work at hand.
So you adjust your constraint management techniques based on the project.
Yes. What works for a small fit-out won't work for a complex hospital. You need the flexibility to choose the right tools and focus for that specific project's unique set of constraints.
What role does technology play in all this? BIM, for example.
Technology is a massive enabler now. BIM is huge for constraint visualization and prevention. That clash detection we talked about finds problems virtually.
Before they cost time and money on site.
Exactly, and virtual walkthroughs let everyone see their project virtually, catching issues early, minimizing changes later. It directly tackles design and coordination bottlenecks up front.
But keeping all that BIM data consistent across teams must be a challenge itself.
It can be. That's why project synchronization is a key capability for BIM servers, ensuring all the different models, architectural, structural, MEP, stay consistent. It's fundamental for model integrity.
So technology helps manage information bottlenecks.
Yes, while person-to-person collaboration is still needed for complex decisions, automated synchronization smooths the information flow significantly.
And what about overall project tracking, spotting those emerging Herbies system-wide?
That requires a good management information system, something that pulls data together to show the overall project status and forecast against the plan. It provides a sound basis for identifying and evaluating problem areas and variances.
Giving you early warnings.
Right. So you can see where constraints might be developing and act proactively, focusing your limited management attention where it's needed most.
Looking even further ahead, could buildings themselves start managing constraints?
It's fascinating, isn't it? The idea of sensor networks transforming buildings into intelligent agents. Using sensing and actuating feedback loops, buildings could dynamically control energy, lighting, HVAC based on real-time occupancy and conditions.
So the building itself optimizes its performance.
Potentially, yes, identifying its own energy bottlenecks, for instance, and adjusting autonomously. It's taking constraint management to a whole new level of real-time optimization.
Underneath all these tools and techniques, though, there's a fundamental mindset shift required, isn't there? It's not just about fixing problems one by one.
That's the core of it. It's moving from isolated problem-solving to continuous system improvement. And Goldratt warned, whenever the constraint is broken, it changes conditions. It is very dangerous to extrapolate from the past.
Meaning, what worked before might not work now.
Exactly. The system changes when you break a bottleneck. So, even the things that we put in place must be re-examined. It's truly a journey of ongoing improvement, not a one-and-done fix. You solve one constraint, then you look for the next one.
Like the Plan-Do-Check-Act cycle.
PDCA is the engine for this. You plan, hypothesize an improvement for the constraint. You do, try it. You check, measure the results, and you act. Standardize if it worked, adjust if it didn't. That iterative learning loop is essential for adapting as constraints shift.
And it requires a culture of questioning, doesn't it? Not just accepting the status quo.
Absolutely. It encourages critical thinking, questioning assumptions, considering different viewpoints. You need that collaborative, inquisitive mindset to dig beneath the surface and find the real Herbies, not just the obvious symptoms.
And in construction, with all its pressures and stakeholders, it means moving beyond blame.
Yes. Issues often get decided through conflict, debate, struggles. Instead of moralizing about who dropped the ball, the focus needs to be on practical, data-driven solutions. Using an adversary process, a healthy debate of ideas based on facts to find the best path forward for the project, for the system.
So wrapping this all up, if there's one big takeaway from diving into the goal and TOC today, what is it?
I think it's realizing that chasing efficiency everywhere, trying to optimize every single piece of the puzzle in isolation is it's often counterproductive.
It doesn't actually move the needle for the whole project.
Right. The real leverage comes from finding that one thing, that primary bottleneck, your Herbie, that's holding everything else back, and then focusing your energy, your resources, your ingenuity right there.
Because when you break that constraint,
the whole system can improve, sometimes dramatically. Goldratt's characters found they had a lot of spare capacity they never knew about, just waiting to be unleashed once the bottleneck was addressed.
So it's not always about needing more resources, but using what you have smarter.
Exactly. It's about increasing output, cutting lead times, hitting goals more reliably, often with the resources you already possess. It unlocks hidden potential.
It really shifts your perspective on managing projects.
It does. It's incredibly powerful.
So our final thought for you, the listener, as you look at your next project or even the one you're on right now, don't just see the tasks, the schedule, the budget. Try to see the system
See the flow, the interconnections.
and ask yourself, what is my biggest Herbie? Is it the obvious thing, or is the real constraint hiding somewhere unexpected, maybe even outside the site fence, just waiting for you to find it?
And remember, finding it is just the start. The journey is continuous. Break one, find the next. That's the real goal.
A great place to end. That's all for this deep dive. Thanks for joining us.